So hello guys, welcome back to my YouTube channel. Today we'll solve the numericals of class 12th physics chapter 5 oscillations. Let's look at the first sum. At what maximum distance from the mean position is the speed of the particle performing SHM, that is simple harmonic motion, half its maximum speed? Given path length of SHM is 10 centimeter. So solution, they have given that a particle is performing SHM and the path length of this SHM is 10 centimeter. So we know that if a particle is performing simple harmonic motion, this is its mean position and these two are its extreme position, and this distance is its amplitude A. So if the path length is 10 centimeter, this implies that the amplitude is half of it, that is A equal to 5 centimeter. And we need to find out at what distance from the mean position, that is from here, is the speed of the particle forming SHM half its maximum speed. Suppose the distance from the mean position is here, that is x, where the speed of the particle is half its maximum speed. So we need to calculate the value of this x. So we have been given that the speed is half the maximum speed. Now we know for a particles performing SHM, the velocity is given by v equal to omega into root under a square minus x square, and the maximum speed is given as vmax equal to omega into a. So putting these two values here, we get omega root under a square minus x square is equal to half of omega a. Now omega omega gets cancelled, and squaring on both the side we can say that a square minus x square is equal to 1 by 4 a square. Now in order to calculate x, let's take x this side, so we can say that x square is equal to a square minus a square by 4. So this comes out to be 3 a square by 4. Now taking square root on both the side, we can say that x is equal to plus minus root under 3 a by 2, which is equal to 1.73 plus minus upon 2 into a. We know that a is 5 centimeter into 5. So calculating this, we can say that x is equal to plus minus 4.33 centimeter. Okay, so this is the distance 4.33 centimeter, where the speed of the particle is half its maximum speed. So hope you understood this sum. Let's look at the next sum. In SI units, the differential equation of an SHM is d square x by dt square equal to minus 36x. Find the frequency and time period. So solution, we know the standard differential equation is given by d square x by dt square equal to minus omega square x. Now comparing this differential equation with the given differential equation in the question, we can say that omega square is equal to 36, which implies omega is equal to 6 radian per second. Now we know that omega is equal to 2 pi f, which implies that frequency will be omega upon 2 pi, which is equal to 6 upon 2 pi, which can be written as 6 upon 2 into 3.14. And calculating this, we can say that frequency is 0.9548 hertz. Now we know that time period t is equal to 1 upon frequency, which can be written as 1 upon 0.9548, which is equal to 1.0475 seconds. So based on this given differential equation, we have calculated the frequency and the time period of the particles performing SHM. Let's look at the next sum. A needle of a sewing machine moves along a path of an amplitude a equal to 4 centimeter with frequency 5 Hz. Find its acceleration at 1 by 30th second after it has crossed the mean position. So let's write solution. We have been given the amplitude a equal to 4 centimeter. So let's convert it into meter, which is equal to 4 into 10 raised to minus 2 meters. And frequency is given to us as 5 Hertz, which implies omega equal to 2 pi f, which is equal to 2 pi into 5, which is equal to 10 pi radian per seconds. Now we know that acceleration is given by a equal to omega square x, and we know the expression for instantaneous displacement x is equal to a into sine omega t. So considering this, we can write x is equal to 4 into 10 raised to minus 2 into sine of omega, which is 10 pi, into t, which is given as 1 by 30th second. That is, we are calculating this displacement at time 1 by 30th second. So this comes out to be 4 into 10 raised to minus 2, and this thing cancel out, which comes out to be sine of pi by 3. Now sine of pi by 3 is sine 60, which is given by root 3 by 2. So we can write this as 4 into 10 raised to minus 2 into root 3 by 2. 2 ones are 2, 2s are 2 root 3. So 2 root 3 into 10 raised to minus 2 meters. Now let's calculate the acceleration. So A is equal to omega square, that is 10 pi. So 10 pi square is 100 pi square into x. X is 2 root 3 into 10 raised to minus 2. Two things will get cancelled out, and the remaining things are 2 into pi square, that is pi square is 9.872. Remember this value, into root 3. Root 3 value is 1.73, and multiplying this we get acceleration equal to 34.2 meter per second square. So let's look at the next sum. Potential energy of a particle performing linear SHM is 0.1 pi square x square joules. If mass of the particle is 20 gram, find the frequency of SHM. So solution, we know that potential energy for a particle performing SHM is given as half kx square, which can be written as half m omega square x square, where k is equal to m omega square, and this potential energy is given to us as 0.1 pi square x square. So putting this value on left hand side, we can say that 0.1 pi square x square is equal to 1 by 2 m omega square x square. So in order to calculate the frequency, if you will calculate the omega, we can easily find out frequency. That is, we know omega is equal to 2 pi f, which implies f is equal to omega upon 2 pi. So let's calculate omega from here. Now from here, x square and x square get cancelled, which implies omega square comes out to be 0.1 into 2 into pi square divided by mass. We know that mass is given to us as 20 grams, so m is 20 grams, which can be written as 20 into 10 raised to minus 3 kg. So putting all the value, we get 0.2 pi square by 20 into 10 raised to minus 3, and cancelling this 2, we can say that we get 10 pi square, which implies omega square is 10 pi square. Now taking square root on both the side, omega comes out to be root 10 pi. So putting this value here, we can say that frequency can be written as root 10 by pi upon 2 pi. So pi gets cancelled, and root 10 is 3.16 divided by 2. So frequency is equal to 1.58 hertz. I hope you understood this sum. Let's look at the next sum. The total energy of a body of mass 2 kg performing SHM is 40 joules. Find its speed while crossing the center of the path. That is, we need to find, that is, a body is performing SHM along this path, and we need to find out the speed at here, that is the center of path, which is also called as mean position. We know for a body performing SHM at mean position, the potential energy is 0 and kinetic energy is maximum, which implies our total energy, which is nothing but kinetic energy plus potential energy, is equal to kinetic energy max, because all the potential energy is given to the kinetic energy at mean position, and as it goes to the extreme positions, the kinetic energy becomes 0 and potential energy becomes maximum. From this expression, we can say that total energy is equal to kinetic energy max. So total energy is given to us as 40 joules, which is equal to Ke max. Now kinetic energy is half mv square. So for kinetic energy max, it will be half mv square max, which implies 40, and this 2 when it goes here, 42s are 80. AT is equal to m v square max, correct, which implies v square max is equal to AT upon m, which is equal to 80, and mass is given to us as 2 kg. So 2 and 80 becomes 40. So taking square root on both the side, we can say that Vmax is equal to root 40, which is equal to 2 root 10, which can be written as 2 into 3.16, which is equal to 6.32 meter per second. So the maximum velocity here is 6.32 meter per second. Let's look at the next sum. A simple pendulum performs SHM of period 4 seconds. How much time after crossing the mean position will the displacement of the bob be 1/3 of its amplitude? So solution, we have been given the time period of the pendulum, that is 4 seconds, and they have said that we need to calculate the time at which the displacement is 1/3 of the amplitude, that is x, that is the displacement is equal to 1/3 of amplitude a. Now we know that x is given to us as a sine omega t, that is based on this equation we can calculate x at any given time t. So putting this value here, we can say that a sine omega t is equal to 1/3 of amplitude a, and a gets cancelled, which implies we can write omega t is equal to sine inverse of 1 by 3, which is equal to omega t equal to sine inverse of 1 by 3 is 0.33. So calculating the sine inverse of 0.33, we get 19.47 degree, which is equal to omega t. Now we know that all things are given here in radans and second, that is omega is radan per second. So we need convert this degree into radan, which is equal to 19.47 into pi by 180. This comes out to be 0.339, which is equal to 0.34 radans. So we can say that omega t is equal to 0.34, which implies t is equal to 0.34 by omega, and we know omega is 2 pi by t. So putting the value of t, we get omega equal to 2 pi by t, which is 4 seconds. So 1s are 2s are pi by 2. So putting this value, we can say that t equal to 0.34 by pi by 2, which is 0.34 into 2 by pi. So putting the value of pi and calculating this, we can get t, which is equal to 0.216 seconds. I hope you understood this sum. Let's look at the next sum. A simple pendulum of length 100 cm performs SHM. Find the restoring force acting on its bob of mass 50 grams when the displacement from the mean position is 3 cm. So solution, let's write what are the things given to us. Length is given to us as 100 cm, which is equal to 1 meter, and mass is given to us as 50 grams, which can be converted into kg as 50 into 10 raised to minus 3 kg, and the displacement x from the mean position is 3 centimeter, and we need to find out the restoring force. So for a simple pendulum, this is its length of the bob, and this is mass of the bob, that is 50 grams, and this is the x displacement, and this is the angle theta that it is making. So we need to find out the restoring force, and restoring force F is given to us as minus mg sine theta, where this negative sign implies that the force F is acting opposite to the direction of the displacement. That is, if displacement is in this direction, the restoring force will act in this direction and vice versa. So in terms of magnitude, F can be written as mg sine theta. Now sine theta is, let's see what sine theta will come. So sine theta will be opposite upon hypotenuse, that is x, and hypotenuse is L, so x by L. So F becomes mg x by L. So putting all the values, let's see what we get F as. So 50 into 10 raised to minus 3 into g. G we take as 9.8. So 9.8 into x, which is given to us as 3 centimeter, which can be written as 3 into 10 raised to minus 2 meter. So 3 into 10 raised to minus 2 divided by L. L is 1 meter. So 1. So multiplying all these things, we can get 1470 into 10 raised to minus 3 and 10 raised to minus 2 will become 10 raised to minus 5. So we can say that F is equal to 1.47 into 10 raised to minus 2 Newton. So this is the restoring force that is acting on this pendulum. Find the change in length of a second's pendulum if the acceleration due to gravity at a place changes from 9.75 meter per second square to 9.8 meter per second square. So solution, we know that time period for a second's pendulum is 2 seconds. So time period is given to us already as 2 seconds. And we know the expression for time period for any pendulum is given as t equal to 2 pi root under L by G. So we know that t is equal to 2 seconds. So 2 equal to 2 pi root under L by G, which implies 2 gets cancelled and L comes out to be G by pi square. So this is the expression for the length of a second's pendulum. Now we need to calculate the change in length if the acceleration due to gravity changes. Now we can see from this expression that length is directly proportional to the acceleration due to gravity, which implies that if we increase the acceleration due to gravity, the length increases. So for the first case, let's see what the length comes out to be. So for G equal to 9.75 meter per second square, let's take L1 equal to 9.75 divided by pi square, and for G equal to 9.8 meter per second square, let's take L2 equal to 9.8 divided by pi square. Now we need to calculate the change in length. So delta L will be equal to L2 minus L1, which is equal to 9.8 minus 9.75 by pi square, which will be equal to 0.05 divided by pi square. Now pi square is 9.872, and dividing this we get the change in length equal to 0.0051 meter. This change is positive, which implies that as the gravitational acceleration increases from 9.75 to 9.8, the length also increases by 0.0051 meters. Let's look at the next sum. At what distance from the mean position is the kinetic energy of a particle performing SHM of amplitude 8 cm 3 times its potential energy? So solution. So first of all, let's write the expression for the kinetic energy and potential energy of a particle performing SHM. So kinetic energy is given to us as half k into a square minus x square, and potential energy is given to us as half kx square. Now according to the given condition, they have said that kinetic energy is 3 times the potential energy. That is, kinetic energy is equal to 3 times into potential energy. So putting these two values here, we get half k a square minus x square equal to 3 into half k x square. So half k and half k gets cancelled, which implies that a square minus x square is equal to 3x square. So a square equal to 3x square plus x square, which is equal to 4x square, which implies x square is equal to a square by 4, which is equal to, we know that amplitude is given to us as 8 centimeter. So 8 square is 64. So 64 by 4. 4 ones are 4 16s are. So this implies that x square is equal to 16 centimeter square, which implies taking square root on both the side, x is equal to plus minus 4 centimeter. So at a distance of 4 centimeter, that is, if the particle is performing SHM and this is the mean position, at distance 4 centimeter, here the kinetic energy is thrice the potential energy. So I hope you understood the sums that we solved today of oscillations, and the remaining sums we will do in the next part of this video. And thank you for watching. Please like, share and subscribe to my channel, and comment your feedback to improve the content on this channel. Thank you for watching.